Well, good morning, everyone. Good afternoon and good evening. My name is Barbara Ryan, and I'm just really excited about being here today for this session. Listen, let's see, we've got a couple slides to show you so that you can see what we're in for the rest of the day. And I'll wait for that to come up. This is going to be a session and actually a dialogue on greenhouse gas monitoring from space. Three partners, the Group on Earth Observations, Climate Trace, and WGIC, the World Geospatial Industry Council, came together to put this really first systematic mapping of both public and private sector assets from space together. This will be the official launch of the report. We've got a number of partners that will be speaking today. And then, of course, we really hope to enter into a nice dialogue with the audience. So again, my name is Barbara Ryan, Executive Director of the World Geospatial Industry Council. And what the lineup for today is going to be opening remarks from me and from Ms. Jana Gevorgyan, the Executive Director of the Group on Earth Observation, Secretariat Director. We'll, of course, launch the report. We'll do a deeper dive into the report, give you an overview of that report. We'll then transition into partners' perspectives, both from Ocean Mind, which is part of the Climate Trace Consortium, and WattTime, who spent a lot of time actually working with us on this report. Hopefully we'll hear from the UK Space Agency, and then we'll go into actually two of our private sector partners, Adina Gillespie from GHGSat and Jeff Guido from Planet, who really, and this is the when I talk about the first systematic mapping, that's where you're going to see insights into the capabilities that the private sector is now bringing to greenhouse gas monitoring from space. We'll then go into the Q&A discussion time. So just very quickly, WGIC is a global not-for-profit trade association of private sector companies working in the Earth observation and geospatial ecosystem. So I want to be clear, we are a not-for-profit organization, but you must be a private sector entity working in either geospatial or Earth observations. And so if there are private sector entities out there listening to this session, please feel free to contact us after the session. We would love to welcome you into the WGIC family. So I guess what I would like to do, just to kind of reinforce the importance of this, you'll see that some material that came out from the climate change folks in advance of COP26 is that they're really hoping that this COP will deliver a couple actions, consigning coal to history, accelerating the electrical vehicle transition, curtailing deforestation, and particularly relevant for us in this particular effort is tackling methane emissions. So we are really, we feel that this collaborative effort that has taken place between and among the three agencies, the three organizations that you saw on the report cover and the title slide, are doing our part to help tackle methane emissions. Next slide. And I will introduce Ms. Jana Gevorgyan, Director of the Geosecretariat in Geneva, Switzerland. And so Jana, thank you personally, and thank you to your team who has spent just so much time working on this particular report. Jana, I'm going to turn it over to you.
Thank you very much, Barb, and also good morning and good afternoon, good evening to everyone who is joining us today. It's really a pleasure to be here, well, in this space, but with all of you on this platform virtually, to do a soft launch, I guess, of this very special joint report. I represent the Group on Earth Observations. It's intergovernmental partnership We're spread across 7 continents, and as of today, we have 113 countries who are working together to mobilize collective action to put Earth observations to be used for the benefit of humankind, for societal benefit. We're not just a group of governments. We are joined in this collective action by over 130 organizations, international and regional organizations that cover the entire value chain of information, from scientific and technical communities to think tanks to UN organizations to development organizations, associations of industry. So we really are a multi-sectoral and transdisciplinary organizations tackling today's global challenges with Earth observations. We're also joined in this effort by 15 commercial entities and civil society organizations. Some of them are in fact participating in the production of this report. Next slide. You know, the world of the universe of global challenges obviously is very vast. So the way the group on Earth observations went about channeling our efforts and focusing our initiatives is by using the global policy agendas as our policy drivers. So we're looking at the kinds of questions that these global policy agendas, including the Paris Agreement, are asking, and then working on a multilateral scale to extract policy relevant insights from Earth observations through initiatives that are turning Earth observations into data packages and knowledge packages, and are then made available worldwide to build capacity around the world, to empower countries around the world to make the most use of this incredible value that Earth observations hold towards unlocking sort of answers to these global challenges and policy questions. So ultimately, we are in service of governments, of countries, as the primary caretakers of the societies and the citizens. So ultimately, we want this information to be used and applied at country level. So to this end, we're working currently on setting up a whole portfolio of practical guidance for adopting measures utilizing Earth observations in climate adaptation measures in particular. We're working with countries to create early warning systems to predict crop failure, to predict floods, to predict droughts, and then take responsible action on the policy level and decision-making level to cut costs and save lives and livelihoods. Ultimately, the systematic use of Earth observations through policy making really drives coherence in policy, coherence in governance, coherence in international regimes. So what we aim for is to inform and influence as many of governmental and intergovernmental processes as possible with Earth observations to establish a common frame for these governance processes to be based on. That is really the solid power that Earth observations hold, is to create a common frame to promote coherence in policy, governance, regimes, and representation. Next slide. So Earth observation, as I mentioned already, are vital to creating informed policy agendas. And one of such policy agendas, obviously, is the Paris Agreement, which is the context for the events taking place in these 2 weeks. Earth observations that are coordinated by a number of intergovernmental and multilateral bodies, you see them on this slide on the left side, they underpin the scientific research and the scientific conclusions that then became the basis for the Paris Agreement, which then really created this milestone policy with governments committing to overall reduction of greenhouse gas emissions and to keep the global warming at well below 2 degrees Celsius. At the bottom of the slide, you see the work that is being also done by a number of partners, including GEO, and that is actually to develop a set of tools, decision support tools, application and services that the countries can then use on top of the mitigation efforts for their adaptation efforts through their national adaptation plans. Next. So to be able to reduce greenhouse gas emissions at the national level and globally, it's obviously very important to have a comprehensive understanding of the current levels of greenhouse gas emissions at the national and global scale that contribute to global warming, and then to be able to monitor the trends and the sources of greenhouse gas emissions. And that is where the satellites come in and the Earth observations come in, but especially the satellites, because while they're not able to measure specific emissions, estimate emissions, they are able to see the overall impact from these emissions on our atmosphere and to be able to create a baseline as well as to show trends. So we are also getting a sense for how well we're doing in our mitigation efforts. Every country ultimately is responsible for their greenhouse gas reductions, and they're providing reporting to UNFCCC under the framework of the Paris Agreement as part of the global stocktake that will actually be officially sort of comprised in 2023. But the countries are already collecting data at the national level through their greenhouse gas inventories and biennial transparency reports to create that body of information, of that database, in order to then create the global stocktake, which will actually assess how well we're doing towards meeting that ambitious goal of keeping global warming under 2 degrees Celsius. And so our work here is actually, for the first time, as Barb already mentioned, to create the systematic sort of assessment of the capabilities that exist in the public and private sector, as well as hybrid missions that enable observation of greenhouse gas emissions from space. This report that's produced jointly by WGIC, GEO, and Climate Trace Coalition is actually an outcome of an event that was held in December 2020, sponsored by UK High-Level Climate Action Champion Nigel Topping and former Vice President Al Gore. It was a forum on innovation in remote sensing technologies for accelerated climate action. And so that event led to the development and the production of this report. As Barb said, this is the first, but hopefully not the very final piece of this collaborative work, and it will be updated, the report and the database especially. The database will be updated as more information about future mission becomes available. And I think at this point, I will turn over back to Barb, who will then turn over to the next speaker to introduce the report in more detail. Thanks, Barb.
Yeah, thank you, Jana. Listen, just real quickly, I would like to build on something Jana just said about using this venue as the soft launch. On the previous slide, the report is downloadable at earthobservations.org. So you can get the report right now off the GEO website. The hard launch will be tomorrow at the UNFCCC Earth Information Day, which is a actually recognized event by the parties at COP26. So we'll go into a deeper dive of the report right now. Sarah Venturini, who's the climate coordinator at the GEO Secretariat, will do that deeper dive. And this report was done under Sarah's leadership. Working for her was Veronica Newmeyer, who did just a lot of work, Aaron Davitt from Watt Time, which is part of the Climate Trace Coalition, Harsha Madaraju, and myself. So this was the team that put the report together, clearly with engagement from both public and private space agencies that had to give us the data to go into the report. So Sarah, we'll turn it over to you. Thank you very much.
Hello, everybody, and thanks, Barbara, for the nice introduction. I'm just going to provide an overview of the main elements of the report. First of all, what it is. It is essentially the first joint effort by public and private satellite data providers to map the current and upcoming greenhouse gas monitoring missions. And this collaboration was established with the objective really to build a bridge between different Earth observation data providers and stakeholders, and especially targeting the needs of climate policymakers and national UNFCCC focal point, who have the need to report to the UNFCCC and Paris Agreement in terms of mitigation efforts and results. And so ultimately, this report will get a full picture of existing capabilities and opportunities of Earth observation being utilized to support mitigation policy processes at various levels, not just international levels, but also national and even at the company level or by cities. Next slide. The report is structured to give an overview of the relevant Earth observation, existing as Earth observation for mitigation, the technical capabilities of satellite missions to measure relevant greenhouse gas data, and then we have highlighted some concrete case studies and examples of those capabilities. The report concludes with some key policy messages that strengthen and highlight the specific and strategic needs. In the next slide, you will see the database that underpins the report. This was compiled through a transparent and very participatory review process involving, as Barbara said, public and private sector entities alike. The team consolidated multiple information sources on mission and instrument data. Primarily, we built on the CEOS mission instruments and measurements database that contains the public sector missions that we built on available literature, review papers. And of course, we collected information from commercial satellite missions by liaising directly with companies and compiled it in a way that could pair with the work done for public sector missions. So as you know, probably most of you know that under the Paris Agreement, there are 7 greenhouse gases that are listed for reporting purposes by parties. In this report, we really focus on the 3 greenhouse gases that are generally recognized as the critical drivers of climate change, namely carbon dioxide, methane, and nitrous oxide. The database then focuses on missions which are able to monitor directly one or more of these 3 major greenhouse gases. And these are missions that are in orbit, in development, or at the end of mission, but that are still providing data on greenhouse gas measurements. And in terms of figures, in terms of figures, we have identified 33 relevant greenhouse gas missions. Most are driven by government space agencies, but private companies are emerging in recent years as strong partners in this field. So for public missions, there are 21 in total, with 13 in orbit and 7 in development and 1 completed. And we know that more are on the way. For private missions, we identify 7 commercial missions, 1 in orbit, and we have a representative here today, and operational, and 1 in its final trial period before being fully operational. In terms of hybrid missions, meaning those involving public and private partnerships, we identified 5 missions, all in development, and these are going to be launched in the next coming decades. In the next slide, you have some more insights from the report. Essentially, the graphic on the left tells us that public and private sector efforts are currently focusing on collecting data on CO2 and methane primarily, whereas the private sector is contributing with the majority of satellite missions at the moment. And private and hybrid missions are increasingly contributing with upcoming satellites, whereas most of them provide specific and point source relevant information and with a strong focus on methane emissions. Also, the report outlines the policy relevant scale of application on the graphic on the right-hand side. And this refers to the potential utilization of Earth observation data to support climate mitigation policy processes at different scales. It's still the previous slide, please. And with point source level, we refer to the monitoring of greenhouse gas emissions from large facility emitters, like large size coal power plants or cities. And you can see here the private and hybrid mission have strong capabilities to monitor point source greenhouse gas data, complementing public sector efforts. In terms of national level, we refer to the monitoring of country level information on greenhouse gas concentration and distribution. And for the global level, we refer to continental or global information. And for both national and global level, public sector missions seem to be, of course, driving the data development with relevant efforts for the global stocktake, which is a process under the Paris Agreement starting in 2023. In the next slide, you can see that we also have 7 policy relevant messages identified in the report. All these messages essentially support the idea that more accurate monitoring will lead to more reliable reporting by governments and other stakeholders alike, and therefore to stronger mitigation policies at all levels. The report really ends with a call for action. We want to support the continued cooperation between public and private sector entities, and we encourage them to take advantage of complementary capacities and synergies to support policymakers in developing national greenhouse gas inventories, and especially in the lead up to the first global stocktake in 2023. So this concludes the overview of the report, and I hope this is helpful to support the following discussion.
Great. Sarah, thank you. Thank you very much. We'll now move into partner perspectives, and we'll start out with Mark Powell, who's an analyst of Climate Trace and Ocean Mind, and again, Climate Trace, and through their participation of What Time, were an author of the report. So Mark, welcome. We'll turn it over to you.
Thank you, Barb. I'd like to thank Anita and the organizers, and I'm really happy to be here representing Climate Trace. And I'd like to share with you some what I consider to be some very exciting developments in tracking greenhouse gas emissions back to their specific sources. Because we believe that climate action starts with a clearer picture, and that means emissions traced back to their sources. Next slide, please. So Climate Trace Coalition was really formed around a challenge. Can we fill the gap in emissions tracking? And the gap is shown in this slide. You can see that most countries' inventories are 5 years or more out of date, and that the inventories tend to be uneven in space and time. And there's a reason why. Inventories are difficult. They require expertise, time, and money. And the result is we have an unclear picture about what's going on, who is producing which gases. Of course, we have a good picture of what gases are in the atmosphere, but for actionable insight, we really need to get down to specific sources and attribution of emissions to specific sources. So as I mentioned, Climate Trace was formed around a challenge. Can we help fill this gap? And the answer is yes. Next slide, please. Climate Trace Coalition members have already had success within their specific sectors. And so the innovation was to realize we could pull sector experts together and really fill the gaps across the board, across all sectors. Here are a couple of examples showing you granular, up-to-date emissions tracking back to specific sources and how that provides actionable insight. So on the left, granular, up-to-date information on power plant emissions allows an actionable insight about wind farm siting and the carbon reduction that's possible. Comparing two potential sites for a new wind farm, one in Kansas and one in Sweden, the existing power plant emissions in these two locations are such that siting a wind farm in Kansas will have a 6 times greater savings in carbon than siting the same farm in Sweden. Now that's an actionable insight that can go to a decision maker and inform productive emissions reduction decisions. Similarly, on the right, you'll see carbon emissions from oil production from 2 nearby oil fields. And the insight is that one field has 25 times more emissions per barrel than the other, and that can inform carbon markets and lead to good decision making. Next slide, please. So how do we do this? Well, in order to track back to sources, we have to supplement the very good insights coming from greenhouse gas sensing satellites. We have to find ways to get linked direct to sources. So how do we do that? Next slide, please. Here's one example for power plant emissions. Climate Trace Partners WattTime and Transition Zero have developed a method shown here in illustration. You see 5 EO images of a particular power plant. And at the same time as these images were taken, we had ground truth data that showed whether the power plants were on or off, that is the activity level of the power plants. Now, combining these 5 observations of power plant on and off conditions and the visible evidence of being on and off, and many other observations with ground truth data associated, we were able to produce a machine learning model that was useful for predicting the activity level of unknown power plants for which we lack activity data. And this model is effectively usable to demonstrate the emissions from power plants around the world. Next slide, please. Here's another example. This is the sector that I work on, ocean-going ships. And in this example, we use radio transmissions from vessels to broadcasting their activity and their identity. And these radio transmissions are detected by satellite and ground-based receivers. These transmissions are for safety purposes, but they're useful for many other purposes as well. We combine this vessel activity data with other information to produce an emissions estimates for each vessel. The time resolution is we can produce hourly measurements, and the time resolution of the information of the emissions data is extremely high. As you can see, we did a test. We knew that the cruise ship sector was greatly affected by the WHO pandemic declaration the week of March 16th, 2020. So we tested our emissions model to see if we could observe a dramatic drop in emissions. And as you can see, there's a very clear signal. Emissions were cut in about half within 1 week, as we expected. So these methods are really providing us with the granular high time resolution measurements of emissions tracked back to sources that we need to produce actionable insights. Next slide, please. So where are we? We came together around a challenge, and we can help. We now have a detailed taxonomy of human-caused emissions from all major sources. That includes power plants, oil refineries, etc. You can see them aggregated in sectors on the right. And again, this emissions inventory is tied to direct observations of emissions, as we refer to it, as close as possible to the emitting event. This enables us to provide the information needed for decision-making and effectiveness monitoring and decarbonizing specific activities. Next slide, please. So here's an example of what you'll see if you go to the Climate Trace website. It's www.climatetrace.org. Here's your dashboard. You can select sectors, you can select regions, you can select time. Each of these parameters, sector, geography, and time, will be getting more and more specific, more and more accurate. Right now, for example, in the region, we have country. Soon we'll be going to sub-national levels. And in addition, we'll be providing attribution at the levels of owners as best we can. Next slide, please. So here's some example of what we call our rapid technological evolution. We are working on additional sectors for which we have some information, but we'd like to see improvements in accuracy. And these are sectors that are particularly challenging. In the agriculture sector, animal feedlots, we do not have a clear global inventory of animal feedlots. So we're working on that, as well as techniques to provide detailed emissions attributed to specific sources. And similarly with landfills. Next slide, please. So the innovation, you can see examples of it on the Climate Trace website in a section we call Trace Places. And here is one example of asset level emissions data that's available today from oil and gas production. Next slide, please. So who is the Climate Trace Coalition? Well, here are the partners that came together around the challenge, and we're being supplemented by work from others, including some of the people on this panel. This information is available on our website, and in particular on our website. Next, please. Next slide, please. We would like to issue an invitation to collaborate. We're hoping to catalyze this kind of activity. This is not something that is the property of Climate Trace, obviously. Many people are doing this type of work. We're pulling together some examples. We don't believe we have everything in hand already. We think that there's much more to gain. We would benefit from access to additional satellite data and processing tools, information that allows us to do AI modeling, for example, ground truth data. And we know there are people out there who can do some of this work as well or better than we can. If you see mistakes, if you see gaps, we welcome contact. You can reach us at coalition@climatetrace.org or on our website, climatetrace.org. You can find contact forms. Please collaborate, join. We welcome the opportunity to find new ways to do this work and provide insights to inform decision-making and decarbonizing. And with that, I'm finished, and I'll hand it back to Barb. Thanks, Barb.
Great, thanks, Mark. Nice job. Say, listen, our next speaker will be Beth Greenway, and Beth is head of the Earth Observation and Climate section at the UK Space Agency. Before Beth speaks, let me just issue an invitation to all the delegates and participants in this session. Please feel free to start using the Q&A or the chat box because we'll have people stay online after the formal presentations, and happy to enter into a dialogue with you. So Beth, let me turn it over to you.
Okay. Can you see my screen?
Yes, Beth, we can see your screen, and we trust you're at the convention because we are hearing a little background noise. So
Sorry, I can't do anything about that. I'm in the green zone of COP at the moment. I've gone to the quietest place possible, but it's yeah, it's quite hard to anything else. Can you hear me? Yeah. Okay. So thank you very so much for the chance to talk, and it's great to hear about this latest report. And I think the words of collaboration that the last speaker just ended on was what I wanted to talk about. Really, I mean, I'm here at Space for Climate in the green zone, where we're collaborating across the UK, but we're a full CEOS members, and it's really, really important to us that the CEOS membership for so many reasons. We work together on what missions fly, collaborating on from the technical levels, how we compare the data sets, and how sure we are that the data can be trusted. And those international standards are so fundamental to building this satellites to be part of the system of systems for measuring our planet for climate action. I just wanted to talk a couple of minutes about, obviously we're talking about methane from space today, and we really recognize what a powerful greenhouse gas methane is. I don't have to read the slides there. It's 86 times stronger as a greenhouse gas than carbon dioxide, and it doesn't persist in the atmosphere as long. However, it's still really important that we know how much of it is present and where it enters the atmosphere. So, and we really recognize that it's a quick win for the climate if we really could identify and eliminate the emissions from coal, oil, gas industries as localized sources. We've got infrared sensors on satellites that you've heard about today to identify the gases in the atmosphere. And existing instruments and missions show broadly where things are, as well as, and I know we're increasing the spatial resolution with some of the satellites we're going to hear about in a minute from the commercial, from GHGSat and Planet. We've also, I just wanted to talk, take the liberty of talking about a new space technology we're developing in the UK to identify industrial sources better than 100 meters. So some of the key technologies, it's a new high-res infrared detector. It's miniaturizing the instrument, so it's got deployable optics on a CubeSat. So it's obviously cheaper and less energy to launch. And this novel methane-specific narrowband filter design, hopefully, will be in a constellation at some point in the future. This is the NIMCAM concept, which is the new UK-led mission with University of Edinburgh. And I think I've just talked ground sampling, 60 meters, with 30-kilometer field of view. We're also working with GHGSat, Canadian company with offices in the UK, and I know you're going to hear from them in a minute, so I won't steal any of their thunder there. And obviously we know that there's other people trying to measure this really important greenhouse gas. I think that's why we want to just, my role in this meeting is to focus on the collaboration. There's a role for everybody in this battle for race for climate action. We need the private sector, the public sector, and academics, industry, government to work together. And I think through the CEOS report, which is talking about the urgency for the improved accuracy of the observations from space, to make sure the actions that we really want can be trusted. The data can be trusted to take those decisions, which do have big financial consequences. So really, just to wrap up from me, just acknowledging really that the space assets are a unique and invaluable tool for climate action, understanding those changes, calculating risks, enabling adaptation and measuring the impacts. And I think methane really comes across in all of those areas. There is huge untapped potential, but we have got existing and planned technologies and missions. Hopefully will help us tackle this problem in the next few years. So, but fundamental to all this is the collaboration and action that's needed by everybody, scientists, policymakers, and business. So that was all I was going to say from my point of view.
Beth, thanks. Actually, that worked out quite nice, and it's good, strong messages. I know the UK Space Agency has been a longtime collaborator and partner in CS, the Committee on Earth Observation Satellites. Just for everybody in the audience, that's the organization that Sarah mentioned with their measurements, missions, instruments, and measurements database. Beth, there was a little issue with the slides. For everybody listening, we're going to provide those slides. Of course, the whole session is being recorded. Beth, thank you so much. I know you've got a million things to do. I hope you know you're welcome to stay on for the dialogue. It's actually quite exciting for those of us that aren't in Glasgow to actually hear a little background noise with all the excitement. So Beth,
it's very exciting.
Okay, yeah, I can imagine. Yeah, so thank you, Beth.
Cheers. Thanks a lot for having me. I'll stay on as long as I can, but with
okay.
Thank you. Bye-bye.
Okay, perfect. Listen, we're now going to transition to the private sector partners that contributed to this report. We're first going to hear from Adina Gillespie, Director of Business Development for Europe at GHGSat. And remember, GHGSat is so on Sarah's graphs, you saw one satellite in orbit, that's GHGSat. There is another one from Orbital Sidekick that's actually in orbit, but they're still in their testing period. So there's, and for anyone that knows satellites, there are often several months, if not even longer, of QA/QC on the data. So we don't have access to that data yet. But Adina, let's go to you as a representative for the private sector mission in this report. Thanks.
Thanks very much, Barb, for that introduction. Let me just take a second here and try to share my screen. Barb, if you could just confirm that my screen share is working.
Yes, see it
Great.
perfectly.
Great, thank you. So thanks to the team for putting together this first report and a first effort that will hopefully see lots of fruitful iterations in the future. I'm going to build on a lot of what's already been discussed today. So like Beth says, methane or methane, as we say in Europe. So I do a little of both if I switch between the two terminologies. Methane is 80 times more potent as a greenhouse gas in terms of the amount of warming potential that it has. And so looking at that warming potential and the industrial contribution to that emissions problem, GHGSat was founded in 2011. So our objective is to provide high resolution satellite monitoring for greenhouse gases. We start specifically with methane because this is, as we've already talked about, a key emissions problem. And actually, in fact, if we look at just in the minutes before this session started, the European Commission president commented that in fact, we cannot wait for 2050 to deal with the methane challenge. We need to cut methane emissions fast. And so let me show you a little bit about the technology that we have available today in the commercial sector to do that. So I think, what we've all been talking about yesterday and today, it's about global transparency in resolving our emissions problems. So I'm just going to lay it out there really plainly from the GHGSat perspective. What is our approach to global transparency? So our data is available for commercial sale. That's the reality of it. It's simplest just to put it out there in the world. We sell this data. We sell it to operators, we sell it to governments, and we sell it to others that actually that are involved somehow in monitoring greenhouse gas emissions. So we're delivering industry-specific applications. And the idea here is about providing actionable insight, exactly as Mark was talking about. It's the actionable insight that really makes the change here. And our data, just to kind of open it up for the science community as well, our data is available for new science applications. We provide that. We provide some of that data for free, and the European Space Agency, in partnership with the Canadian Space Agency, manages that program. And we also have a global good initiative where we provide a global map of right now methane emissions, and that will include other greenhouse gas species in the future. It's called Pulse, so you can see that on our website. And it's a free tool for people just to see what emissions look like over time in a really simple interface. And then I'm going to echo something everyone's been saying. It's all about collaboration. So for us, the way we achieve a change in the world is really about working together. And what we found in delivering the greenhouse gas monitoring services is that we need everybody. So you see this map that I've included on the slide, the European Copernicus Sentinel-5P satellite that provides a global daily coverage at a lower resolution. So we need that global coverage to look at those really big regional emissions issues. And then we also need to pinpoint where they're coming from. And that's where we come in with GHGSat and our high resolution capability. So today we have 3 satellites in operation. Next year, we're launching another 3 and another 5 in 2023. So I'm going to walk you through really quickly, in the interest of time, I'll just walk you through some examples of how we're delivering results today. So this is an example of an underground coal mine that we've recently imaged. You can see in this image, the background is a high resolution optical image, so that helps us mentally position ourselves. And then these plumes that you see popping out, those are coming from coal mines. So these are our methane plumes. Oh, let me go there. So that's an example zoomed in of what we're looking at. And then, you know, at this kind of resolution, we can get right in there and actually identify exactly what vents these types of emission sources are coming from. And this is where we come in and help the operators resolve the issue. So again, looking at that low resolution, it helps us for what Sarah was talking about, these global policy initiatives. And then we also need that actionable insight that Mark was talking about to help the operators actually address the problem. So here's another example of how we're doing this for landfills. This is a domain that's really quickly evolving. We've got a lot of work going on in this area, working with operators and with the scientific community. So this is just one example of a methane plume that we recently detected in South America. And for those of you with a keen eye, you might note that there's a straight cutoff point at the end of that plume. And that's because it's the end of our satellite image that overlays. So for those of you that are watching for that bit. And then my final example for you is on oil and gas. So you can see here an area of the Permian Basin in the United States, and you can see how close these oil and gas facilities are. You can see the well pads really quite close together. And if you look, you'll see a methane plume right in there. And you can see in this image, if we were to kind of just look at it without the plume, why the high resolution matters and why multiple data sets matter, because the direction of the wind could actually make a difference in telling us which site this emission source is coming from. So it's that high resolution capability combined with the detection threshold that allows us really to pinpoint these for that actionable intelligence for the operators. Just a quick comment on performance. So we have done testing of this technology. So, and this is just one example, together with Total, we conducted a blind test of our system. So there was a controlled emission, and we didn't know where it would be or when or how big it would be on this site, this test facility in France. And you can see here that the spacecraft is performing really well in our ability to detect those emissions reasonably accurately. And then it all comes down to delivering results, and that's about the analytics solution. So for us, we have our own portal where we deliver for operators, governments, and others. We bring in different layers of data, different resolutions, and different types of data. It's not all about Earth observation. We need the operators, we need the other databases out there that exist. And this is the portal through which we deliver our services. So I'm putting this up. I spoke at an event a couple of weeks ago where I was asked, what does the next generation of satellites look like? And this is a great question. We love to talk about the technology. We love to talk about the sensors and all that jazz. But really what the next generation looks like and needs to look like, it comes back to collaboration, collaboration, collaboration. We need to have all these technologies in our toolbox in order to respond to the immediate and pressing call for action in response to the emissions challenge. So thanks for your time, everyone, and I look forward to the discussion.
Great. Adina, thank you. And listen, thanks also for referencing back to Sarah's remarks and Mark's and your point that helps all of us tie some of those loose ends together. So I appreciate that. Jeff, last but not least, Jeff from Guido from Planet is the mission director for Carbon Mapper. And I just want to be clear, while Planet is another private sector company, Jeff's going to be talking about the hybrid mission called Carbon Mapper today. And I see that some questions are already coming into the chat box on hybrid missions. So Jeff, over to you. Thanks.
Thanks, Barb. I'm going to share my screen real quick. Give me a moment. All right. Good afternoon, everyone. I'm very happy to be a part of this discussion, and thank you for inviting me to the organizers as well. My name is Jeff Guido. I'm the mission director for the Carbon Mapper mission at Planet. As Barb mentioned, this is a public-private partnership. We'll talk more about this, I guess, in the Q&A section. But Planet is a private company, and we've partnered with a number of other organizations, which you'll see listed in my last slide, to bring about a mission or a program that's greater than the sum of its parts. And what I'm responsible for in that respect at Planet is I drive the engineering and the business activities at Planet across the company in support of the Carbon Mapper mission. The Carbon Mapper mission itself, the primary use case is to deliver a system or a constellation of satellites that can locate and attribute methane point source emissions at scale, or at the facility scale, and be able to get us to a long-term solution for having a complete vision or view of what's happening on the ground. So it's been hammered home I'm sure over these 2 weeks, but even just in this series of remarks that we've seen over the past hour about the potency of methane. We all know how potent it is, and since methane point source emissions, since they represent a pretty large number of the planet's anthropogenic emissions as a whole, we're developing the Carbon Mapper platform to reliably locate and attribute these super emitters. This is so that operators and regulators, industries such as fossil fuels, waste management, and agriculture, have the data that they need to actually mitigate these emissions in a tight feedback loop. Assuming we reach the point where we're providing regular coverage globally, we will have the data to address emissions at scale and make significant strides towards these near-term mitigations. Such data can address many ESG-like indicators as well, in areas such as environmental justice, air quality, and health concerns. But you'll see across the bottom, you see there's a number of examples of how we can see and locate and attribute different emissions at different levels. So we're currently in development with a couple of satellites, 2 satellites, in fact, for a demonstration mission to demonstrate a really high performing imaging spectrometer that's able to see methane plumes, carbon dioxide plumes, as well as many other types of bands across the visible to near or shortwave infrared range. After we have demonstrated this high performance, our intent is to roll out a full constellation of satellites that will have a daily revisit capability at the 30-meter GSD or global spatial geospatial scale. These satellites have a very large onboard storage capacity and have quite a bit of performance in its downlink capability. Now, methane is only a handful of the bands that we're planning to be able to see with the spacecraft. So our intent is to commercialize and develop additional products outside of greenhouse gases that leverage the other bands that the satellite is capable of imaging. A little bit on the history of the program. Things really started in earnest in 2016 when the Jet Propulsion Laboratory began collaborating with the state of California for the California Methane Survey. This was a survey that was mapping a large number of the inventory across the state of California and has informed a lot of our a lot of our insights and theory have changed for the mission that we're in the program that we're currently executing now. Over the next few years after that, the mission gained quite a bit of momentum through gaining additional partners such as Planet and a variety of philanthropists. And we started to craft a program that would have aligned incentives and drive towards a long-term goal of having a daily revisit constellation that could do the things I've just outlined, but also be commercially viable. After we really forged the coalition in the fall or December of 2020, we really began heavy development or major development on the system itself. We announced this publicly in April, and we also announced additional accelerators worth of funding in October, just last month. Now, the program is structured in 3 major phases. We've already completed phase 0, which was the incubation phase, or the phase where we were looking at the different pieces of the platform to make sure that we could deliver on engineering and business fronts. Now that we're in phase 1, all of our efforts are focused on getting the first 2 demonstration satellites into orbit, as well as having a robust platform that's able to roll out the data products that are needed for decision makers. Planet will develop and operate the spacecraft as well as the data processing platform. And our partners at carbonmapper.org, as well as some of our other partners, will be releasing the methane and CO2 data on an open portal so that it can be used by decision makers globally. After we've demonstrated that this is viable on all fronts, our intent is to launch a constellation of satellites that will hit that daily revisit capability that I've already mentioned. And we believe it'll be comparable to the size of our current SkySat constellation. SkySat is, if you don't know, is a set of satellites that are around the same size as the Carbon Mapper satellites, all small sat class. And they also have a daily revisit capability that's pretty high performing for our company. So we expect that this constellation will be a similar size. And the whole intent is to really just increase the overall capacity of the system so that we can see everything we want to see, all the high priority targets on a global and daily basis. Another video for you. This is the first time that we're showing this one publicly, but this is something that we created to show how the mission comes together in some ways. The primary imaging mode of the Carbon Mapper spacecraft will be a strip mode collect, which is able to collect a large area at a single time. And from those strip collects, we'll be able to pick out methane plumes in different areas. So this is the example here is of the Permian Basin, where there's a high density of oil and gas wells. And we believe that with this type of capability, we'll be able to pick out and pull out a large number of plumes in a single pass. So doing that and repeating that revisit with a low latency will give the decision makers the ability to make decisions on that tight feedback loop that I already mentioned. And to start to wrap up, looking ahead, Carbon Mapper is part of a larger ecosystem of emerging methane monitoring systems. We've heard from GHGSat about collaboration, and we believe that there's something to that as well. Most of the players are complementary in that we all are able to address the methane problem or the greenhouse gas problem from different ways. And not just from space, but also there are terrestrial and airborne assets that can be put to work as well. And if we can make sure that we have the proper interactions and can have the proper interfaces between those organizations, we can leverage tip and queue activities and others that allow us to make the best use of the platforms in regards to their strengths. The key data gaps that we believe that at Carbon Mapper that we'll be able to address have to do with completeness. Due to the size of the constellation that we intend to launch, we believe that we'll have a pretty good view on what's happening on a daily basis. Our ability to attribute or be specific about where the methane plumes are coming from will give a lot of empowerment to those decision makers and operators on the ground. And the low latency of our systems will enable us to make change or drive change quickly. We also want to make sure that we are accelerating this near-term methane mitigation opportunity that we have. There's been multiple announcements about how the time is now to do that. And with timely data, that's something that operators can use. And then finally, this is what underpins all of this is a very unique public-private partnership where we have private companies such as Planet and public organizations, as well as NGOs and philanthropies working together to complement each other's strengths and drive towards a very powerful and strong program. The final note that I'll make is there's a number of other products that this system can start to work towards. While methane is the most developed one that we have right now, we believe that we'll be able to drive towards insights and indicators for agriculture, biodiversity, and water quality, as well as others in long term. But our primary use case has to do with greenhouse gas emissions. So that's all that I have for today. Thank you for the time and the opportunity. If you would like to learn more, please look us up at either planet.com or carbonmapper.org, and we'll answer your questions. Thanks.
Great. Jeff, thank you very much. Really appreciate that. Listen, we're about ready to transition into the question and answer and the discussion period. Before we do so, let me ask Veronica Newmeyer, Aaron Davitt, and Harsha Mataraju to share your screens as well. You guys all contributed to the report, and so you're here to answer any questions that the rest of us might not be able to answer. Listen, but let me just build on Jeff's last point for the first question, because it was a question from Andy Bennett. And actually, Jana, it was targeted to you, but I would also offer Jeff an opportunity to weigh in. And it was largely kind of the benefit of hybrid. You made some references in your talk, Jana, I think, about kind of building, shoring up the strengths of one and building on shoring up the weaknesses of the other and leveraging the strengths of one. So let me ask you to talk about that. And just before you do so, in Jeff's remarks, this is for the whole audience, he did mention public, private, and philanthropic funding. And that's the first that we're starting to see emerge into this field now. Jana, first to you.
Well, thanks, Barb. And Andy, I think, typed the question before Jeff actually spoke about Carbon Mapper. So maybe Andy already got the answer to the question from Jeff's presentation. I'll just say, I think as it was highlighted by Jeff, these missions really build on the extensive experience of the various players that come into the partnership, really playing to their strengths. In the example of Carbon Mapper, as Jeff said, it sort of built on the insights that came from the partnership between California State and JPL. So then the further development of the technology could really leverage that. I think an important probably highlight here as a benefit of a hybrid mission is, it comes from the business model, is the type of access to data that comes with it. In the private missions, I think mostly we're looking at paid subscription, providing access to data sets and services. And these types of missions, we do expect to see more open access to data, while the more bespoke kind of services are probably going to be based on subscription services. But again, I think Jeff can keep me honest here. I hope he will. And fill the gaps or correct me if I totally misrepresented the situation.
No, Jana, thank you. That's pretty close. I'm as a key member of this partnership for Carbon Mapper, we really spent a lot of time thinking about how do we make sure that, because we're so many diverse organizations, how do we get to the same place together? And so spending a lot of time around really aligning incentives, kind of like how I mentioned earlier, was really key to make sure we stay on the same page. Now, it's the term public-private partnership was something we started using because because of the organizations that we have, and it does complement one another. But I think for really what you can take away from this is we have space missions are hard. They have a lot of complex parts, a lot of differing fields that need to weigh in. I mean, you have all the engineering with the spacecraft, you have the you have the data processing engineering, but beyond that, you have to have science that underpins it. You need to have the marketing and business acumen to make sure you can deliver. You have to get the funding from somewhere. You have to make sure that you work with the government to make sure the regulatory processes are aligned with your intentions. And so pulling these partners together allows us to really have punch above our weight class in many ways. Now, the drawback in some ways is there's a lot of coordination needed. I spend a lot of time working with my partners and making sure we're continually aligned and making it so that the interfaces between the organizations are working well. So it can be cumbersome at times, but I do think that we're going to achieve more than like just Planet would have achieved on its own.
Thanks, Jeff. Thanks, Yana. I will just weigh in on this point because, there are very different functions between the public sector and the private sector. And I think for everybody, I've been a long time advocate of broad open data policies on the public sector side, paid for by citizens and taxpayers, and they should have access to every bit of that information. We do recognize the private sector has a different business model, yet we are still seeing, whether it was Adina's mentioned that their data is available or open to some researchers, or Jeff, I know that Planet has negotiated a deal with Norway, so you're opening up some of your other data to folks that are doing work in the tropical rainforest. So we are seeing changes there, but I also don't want to forget the different roles and responsibilities that the public and private sector have.
Yeah, and let me, sorry,
yeah,
Barb, let me
ahead.
just add to that. Yeah, the NICFI contract that you mentioned with Norway is for PlanetScope and our base maps. And so that is an awesome program that's a little bit aside to Carbon Mapper.
Right.
Even though Planet is, and we intend to make this constellation commercially viable in the long term, all the methane and carbon dioxide data will be available to the public as a public benefit for use through our carbonmapper.org partners. So I think that's a key point and something that we believe is a unique aspect of the program. Yeah, this will be available after a period of time, except in emergency situations in which we'll make the data available immediately. But all of it will be available through carbonmapper.org.
Yeah, thanks, Jeff. And so I hope the person that asked the question, Andy, you in the audience, I hope you got it, because that does speak to Yana's about leveraging the key functions of each of those partners in a hybrid mission. Mark, there are going to be a couple questions for you. So does transport include cars and domestic vehicles? Sorry if I missed the information, but is there evaluations of your emission estimates with those inventories? And there might have been another one farther down that I'll come back to you. But Mark, let me turn it over to you right now.
Yeah, thanks, Barb. And Allison Hall, thanks for the question. Transport does include cars and domestic vehicles, but it's a difficult sector and there's a need for improvement. And so if there's ground truth data out there that we can use to improve our estimates, please reach out and contact us. But for now, it does include cars and domestic vehicles. And then the second question, we've been through an extensive validation process and comparing our emissions estimates with existing inventories, and Aaron was involved in that. It's difficult, and the inventories are usually a little bit different than each other, but we've gotten pretty good results comparing our bottom-up source-specific emissions estimates and aggregating them into a sum and then comparing with the overall inventories produced by others. So we're using that as an important validation step. And thanks for your question, Matthew.
Mark, there is one more for you from Mark Dowell, who actually has been just a leader, a champion in this entire field, both on the CS and largely on the CS side, the Earth observation side for climate monitoring. And he's asking, in the future, do you see these sector level assessments and attribution efforts being on demand, or kind of a services systematic mapping and assessments at a global scale?
A great question, and this leads into an opportunity to speak to our ambition. That is what we hope to achieve. Climate Trace has a very high ambition. We aim to produce global asset level emissions inventories in near real time, available on demand. So whether we get there depends on how much collaboration there is, but we are producing this material and putting it into the public, so it's available on demand. I think that answers your question. I'm not sure what services systematic mapping means.
And then Mark, feel free to weigh in. I'll go on, but if you want to supplement that question, because I may have botched it too, feel free to do that. Mark Dowell. Adina, I'm gonna hand this one to you, but you know what, I feel a little bit awkward doing it. Of course, I would invite anybody on the panel to jump in. The US president today announced a pledge to cut global methane emissions by 30% by 2020. Do you think this goes far enough? And what would be your ideal collaboration to help enable this reduction? So we're walking out into that political turf now, but feel free to weigh in if you would like to, and I'll offer it up to anybody else as well.
Wow, that's a great question. Thanks, Barb. I'm not going to weigh in on the political debate about what that number should be. That would be well outside my wheelhouse in the commercial sector to do something like that. So I'll focus on the second part of the question. What would we see as an ideal collaboration? There's a couple of elements to it. One, I think the first thing is to recognize that what the commercial sector is doing is not in conflict with what the public sector is doing. Those two things can and should complement one another. And there are all kinds of ways that we can put together collaborations that do things, that provide the data to organizations that need it in an urgent way. And I'm reminded of, during my academic life, I had the great fortune of interviewing one of the leaders in NOAA who helped to make the weather satellite program happen. And I asked him the question, how did you do it? How did Russia and the United States come together in like the heat of the Cold War to put together the world's, global weather monitoring system? And he said it was really simple. We all knew each other. He said we sat at the table and we talked to each other. And when things got tense, someone made a joke and we engaged with one another. And that personal relationship is really an important part of the collaboration and a willingness to work together. So when I look at our ideal collaboration in GHGSat, just to give you a quick example, we had a great case last year where we had the Sentinel-5P. So this is the public mission coming out of the EU. We were working with their principal investigators in their labs on an emission that we had identified quite by accident in the high resolution imagery. And we knew this was coming from an oil and gas facility in Central Asia. And so we immediately reached out to various diplomatic channels to try and have this emission source, stopped, actually, to get in there and mitigate it. And I'm happy to say it did stop for quite some time. And that one emission was the CO2 equivalent of 1 million passenger vehicles on the road for a year. So we can, if we're willing to work together in collaborative ways, work quickly in response to the call for action. I think to me that's what an ideal collaboration looks like. It's about the willingness to think outside the box and make sure that it's clear we're not in conflict with one another.
Adina, thanks for that. I think both you and Jeff did a great job with the animations or some of the graphics that show the really wide swath coverage that a public sector mission brings, and then the more targeted private sector missions. So thanks for putting that in a graphic. Does anybody else, Yana, Mark, does anybody else want to weigh in? Sarah, yeah, Yana, you've got your hand up on that last question about collaboration. Go ahead.
Yeah, I thought Adina was going to go there, but she stopped just short, I think, because she knew I was going to come in with this very clairvoyant of her. But I think in terms of this collaboration between the public and private, for those who will read the report, they will see that one of the key messages, actually, because we just described how all of these capabilities can really help us have a better understanding, do a better assessment of the emissions. And if we want this capability to really influence national action, then there has to be trust developed by the parties, by the national actors, to be able to actually take on board this information that's coming from privately operated assets. And I think that is a really important thing to focus on, is and we in GEO do see that as a massive sort of thing to advance, is to make these public-private partnerships so sustained and so systematic that we cultivate this trust-based relationship and this cultivate the culture of trusting one another, so that these kinds of assessment of greenhouse gas emissions can in fact be taken on board by the parties in sort of informing their reporting, in informing their national level actions to reduce and mitigate greenhouse gas emissions. So it builds on this interhuman relationships, interpersonal relationships. Ultimately, that's really what builds and develops that trust. So that's what I wanted to add.
Great.
I could add one more quick point. I think rhymes with what both Adina and Jana are saying, but we are trying to fill a data gap, and so I think we've crafted a pretty great collaboration, but where we could go further is more and sometimes deeper interaction with governments that have committed to using that data to fill their own data gaps and drive their own policy and decision making. I think that's where we think this could be taken further, because if you just put data out there, it doesn't necessarily mean it's going to be used. And we've learned this the hard way at Planet, and we've overcome many of these challenges. And now we have a new data set that's coming from many actors. And so being able to either fuse those or work those in a harmonious way, but also that additional next step from the governments or other empowered players to use that data in a true way to fill their own blind spots, I think is really what would be the next step in a collaboration.
Yeah, Jeff, I think that's an important point, because just going back in time, when I think about the early deliberations in CS, the Committee on Earth Observation Satellites, and maybe a little bit to this day, there's still competition among governments and individual space agencies on who's going to do what first. And that, just building on Jana's point, that changes over time. It gets better over time. I think we're actually going to see more private collaboration go on in the future too. It may take a while because you are competitors as you come into this field, but just like on the public sector side, I think we'll see more of that over time as well. So thanks. There is a question, is the Pulse feed available through an API as a native data layer? Is there a cost, or is that a cost or an open access layer? And then again, syncing with SP5 is just really great. That's from John Metzger.
Yeah, thanks, Barb, and thanks, John, for the question. That's a very specific and salesy question, so I'll be really quick about it. But the Pulse visualization is really just meant to be a simple login that people can go and have a play with. So we don't push it out as an API. That's part of the commercial service that we deliver, that we're very happy to deliver, but we haven't set that up for a free feed yet. Thanks for the question, though.
And there are two last rather technical questions, so I'm not sure who wants to weigh in on this. Let me read them both and you can think about it. Is methane emission a proxy for other types of pollution, i.e. if there's a methane plume, are there more likely to be other forms of pollution happening from the same source? That's from Niali Robertson. And then there's just one other question on, I'd like to know how to monitor the emission density and how that contributes to understanding the total emission volume. And what I'll say is, if we can't answer, well, the second one in particular, we have a name, and Carlos Cow, if you send in your email address, we will get back to you on that. but let me turn it over either the proxy for other sources of pollution. I can see certainly on the landfill side, let me jump in on that. On the landfill side, while they're emitting gas, clearly there's an effect of landfills on groundwater contamination globally. And so I think, Mark, it was you that said you're trying to put together a data source for landfills globally. That's going to be really important. But anybody else, feel free to weigh in on either of those questions. I'll go back on mute.
Yeah, I'll jump in there, Barb, just really quickly. So on the proxy, yes, like you say, the landfills is one example. There are others. Methane can be a proxy for hydrogen sulfide, which is, you know, a really harmful element for us as humans. So yes, it can be. There's lots of studies on this kind of thing, and yeah. We won't dive into it here, but the answer just at the top level is yes. And in terms of monitoring emission density, I'm just going to draw maybe one point to everyone's attention. It's look, I mentioned it really briefly on one slide. That the key thing that we need to understand when we're doing these types of analysis is wind. This is the greatest source of error in what it is that we as a community are trying to do in terms of associating emissions with their location. The wind really needs to be understood in order to do that, to solve that problem properly, and it is quite a source of error. So for us in GHGSat, I'm sure for Mark and for others, you know, we're pulling in all kinds of weather monitoring data to get the most accurate results there. So thanks for that.
Okay, thanks. Aaron Davitt, what time, and one of the key researchers on this effort, Aaron.
Thank you. Yeah, just to add on to the proxy for other pollutions, with the with the CAFO work we're working on, not only is it to understand the CAFO locations to get methane emissions, but also CAFOs can be a source of groundwater pollution too. So there's also other useful secondary measurements you can get, or questions to answer by just knowing the locations of these methane sources.
Thanks, Aaron. Well, everyone, I am seeing no more questions in the chat box, so I think this is probably a time to wrap up. I will just offer everyone on the screen a minute for any closing statement that you would like to say, and then I'll come back with just make sure people have access to the report one more time. So it's not necessary, but if you have one more thing you'd like everybody online to know, jump in and we'll manage those interventions. All right.
Well, because it's me, I can't resist the opportunity. I'm going to build on what Jana said about trust and you know, on the data side. And actually, I'm going to give a shout out to the European Space Agency. The Earth observation director about 5 years ago was really visionary about exactly this thing, and how do we combine these public and private capabilities in a way that people can trust and be comfortable with. And so they put together a program for evaluating new space data, and they actually do a deep dive to assess all these data sources, and that sort of almost stamp of approval, if you will, kind of it gives comfort for people in bringing it into the public sector. So I couldn't agree more, and I hope that we'll see more initiatives like that one that do quick assessments and bring down the barriers. So thanks for the opportunity, Barb. Thanks for the point, Jana, and my last comment is just thanks to the organizers. This has been great.
Good, thank you, Adina. Mark, go right ahead.
Yeah, thanks, Barb. I'd just like to add that as we began the Climate Trace effort, we were all optimistic and ambitious, and I've been really impressed at the level to which we're able to understand emissions linked sources. So I think we're really on the verge of a great improvement in our ability to understand emissions and their link to sources, and the methane plumes, that the work that's been ongoing is really going to be a great step forward for that. So I think we're we're really seeing rapid progress, and it's very exciting. And I really want to emphasize that. Thanks.
Thanks, Mark. Sarah, do you want to, I know it won't be a live session for many people, but do you want to just do a quick call out or shout out for tomorrow's Earth Observation Day for anybody that might be interested in that?
Sure, thanks, Barb. So as you and Jana mentioned before, the hard presentation, the hard launch will be tomorrow, where the whole of systematic observation community will be gathering. It's called the Earth Information Day 2021. It's a now regular mandated event under the UNFCCC that happens every year at COP. This is a way for policymakers to get to know more about the progress done by Earth observation providers, including international cooperation agencies and space agencies, but also other partners like WMO working on in situ observations regarding the support that these observations provide to climate mitigation policies. And so I would like to invite everybody to join. I provided the link to the Earth Information Day website on the chat, in the participants chat, so you can find it. And yes, the event will be live at COP in Glasgow. There's going to be a UNFCCC segment in the morning and a UK presidency segment in the afternoon. So please feel free to join if you have access as delegate. If not, we will provide you some information about the outcomes on the GEO website with a nice blog post after COP. Thank you.
Great, thanks, Sarah. Listen, I am seeing a request for a little additional information from Carlos. So we have his email address. Carlos, if you're still online, we'll get that to you. And oh, I'm sorry, there is one, this is a question for Adina and Jeff. What kind of synergies do you think will be created by collaboration between high resolution point monitoring satellites such as GHGSat and Carbon Mapper? Masa Haya came in with that question, which I actually think we kind of talked about it before, but Adina or Jeff, if you want to just jump in real quickly before we sign off.
Sure. Yeah, I think there's actually a lot of commonality between the types of imaging that both Carbon Mapper and GHGSat provide, but also want to expand the aperture, so to speak, to other systems that are coming online or are already available that can provide complementary sort of assessments. So there's MethaneSat performed by EDF and Tropomi on Sentinel-5P, which all have different basically scales in which they can see what's happening on the ground. And so these are the types of things that I think that there need to be. You can do tip and cues. So like if one satellite sees something, then another one can take a closer look or another look just to verify, make sure that that is actually a plume, or sharing data to a common source or a common output, so that there is that sort of fusion and harmonization across the platform. So there's a number of ways that you can do it. There's a lot more to this that I can provide detail for in just a short answer, but that's something to think about.
Dina, last.
Yeah, I echo those comments. I mean, we've been working with the scientific community on the tip and cue for a long time, and these techniques are pretty sophisticated at this point. And for our part, I mean, we've been doing this for a while, right? Our first satellite launched over 5 years ago. So it's really, it seems a bit strange. It could be perceived to be a competitive landscape, and it shouldn't. There's lots of opportunities for organizations, public, private, whatever, to be working together in response to the global need for an answer to this problem. So I know we've been in discussions with lots of different organizations organizations, Planet Carbon Mapper, others, and like Mark's call to action, call for an invitation to collaboration that needs to exist across the piece. So thanks for that.
Good last point. All the missions that Jeff just mentioned before Adina's intervention are listed in the report. So it's public missions, private missions, and then hybrid missions. Again, the report's on the GEO website, earthobservations.org. We'll be putting it on our website, wgiccouncil.org, and you may find the same at WattTime or Climate Trace. So you should be able to easily get the report. Again, feel free to join the team tomorrow to listen in on Earth Observation Days, because a host of other organizations like CS and CGMS that have done a lot of the work on the public sector side will be presenting. Anita, I'm going to turn it back to you. Thank you, everyone, all the partners on the effort, all the presenters here. I very much enjoyed the time this morning for me, afternoon, and maybe evening for some of you around the world. Anita, we're going to turn it back to you. So thank you, and thank KTN for hosting this event.